Hello, everybody, and welcome to the week in which we talk about how hearing works. Unlike the weeks past, where I've given you a slide about vocabulary for this week, in these slides, you'll note that a lot of what you're going to be looking at is vocabulary, and so we're going to talk about that as we move through the process. Of understanding how the ear works. So why do we need to include this as a part of this basic understanding of speech and language development? It's because as we've spent this last few weeks talking about how speech and language develops, we've looked at the speech chain from one perspective, from this perspective of the child being the speaker. And we have to remember that in the speech chain, there's that two-person, two-participant component in which we also have the listener. And a child's speech and language is also impacted by what they hear, just as much as we are talking about what they say. So you will get more information on the anatomy that is related to speech and hearing development, but we need to give you just this little snapshot of the impact of hearing so that you have a complete picture of what that speech chain looks like and the impact that the listener component of the speech chain has. This first slide is a big picture of what the structure of the human ear looks like. And so you need to know the vocabulary that is on this slide and be familiar with it. You're going to discover, as I will repeat throughout the slides, that the structures of the ear, ironically, have more than one name often. And so I will give you both names that are typically used. You'll just find a lot of synonyms that are commonly used to talk about the parts of the ear. So this is the basic structure, and you'll see that on the bottom of the slide how the ear is broken up into three main parts: the external or outer ear, the middle ear, and the inner ear. And we're going to break down each piece of that and talk about how each of them play their role in the process of hearing. So this is kind of gives you the written form of all the things that we're going to talk about in the next few slides, written out for you to kind of process and read through. Let's start with the outer ear. The outer ear, that piece that we hang our earrings from, right, is called the pinna, or the outer ear, and then it is the one of the two components of the outer ear, the other component being the external ear canal, also known as the external auditory meatus. So here we start with those pieces of the ear having more than one name. The purpose of the outer ear is to funnel sound into the ear canal in order for the listener to participate as a part of that speech chain. The pinna's design is a bit like a funnel, and it takes and localizes the sounds and directs them into the ear canal so that they can begin the process of being interpreted by the listener. Once that sound wave that has left the speaker arrives at the pinna and it is channeled or tunneled through the external auditory meatus, it arrives at the middle ear. The middle ear has some components that also have more than one name. They are called the tympanic membrane, also known as the eardrum. That might be the term you're more familiar with. And then it has three small bones. In fact, these small bones are the smallest bones in the human body. These three bones together are called the ossicles. They are the malleus, incus, and stapes. The malleus, incus, and stapes also have different names: the hammer, the anvil, and the stirrup. If you look at the stapes, you'll see the bottom of it looks a bit like a stirrup that you might see when riding a horse, and that's where it's got its name. The bottom of the stapes is an oval-shaped bony piece that is attached to the oval window. The oval window is the opening to the inner ear. So let's talk about the job of the middle ear. That sound wave travels through the external auditory meatus, arrives at the eardrum, and the eardrum vibrates with that perception of that sound wave that has arrived at the middle ear. That sound wave then is channeled through the ossicles, through the malleus, the incus, and the stapes. And if you think about them almost like a mechanism, like a, a line in which one moves the other. It's where the sound wave is changed into mechanical energy. It moves just like a machine might. So the sound wave vibrates the eardrum, which vibrates the malleus, the incus, and the stapes. They move, causing emotions that changes that sound wave to mechanical energy. The bony plate of the stapes or stirrup that attaches to the inner ear will then serve to send that mechanical energy into the inner ear. This will describe to you in, again, written form of what happens in this hearing process. So that stapes that we saw, that bony plate that is now moving, it's going to send this movement towards the inner ear. On the other side of that bony plate, on the other side of that oval window is fluid or liquid. That fluid moves and creating hydraulic energy that moves over the hair cells of the cochlea. The movement of those hair cells creates an electrical energy, a neural impulse that is sent through the auditory nerve to the brain, and that's where the brain gets to interpret the message that was originally received by the outer ear. So let's look at what the inner ear might look like. So again, on the left-hand side of this slide, you'll notice just the top part of that stirrup. And you can see the oval plate that's attached to the oval window. The stirrup, being a part of the middle ear, is attached to the cochlea, the oval window in the cochlea. That moves the fluid through the cochlea along the hair cells. This fires up the auditory nerve. The auditory nerve sends the electrical energy to the brain where it's interpreted. Notice that there's more than just the cochlea, the snail-like portion of the inner ear. There's also those loops that look like they're on top of the snail-like portion, and those are called the vestibular labyrinth or semicircular canals. These are responsible for our balance, our equilibrium. It tells us where we are in space and time, whether we're laying down or standing up, whether we feel like we're moving. These are the parts of our body that tell us that give us that information, that send that information to our brain. So while we understand the process of the sound arriving at the outer ear as a sound wave, that it changes to this vibration at the tympanum that moves the ossicles, creating mechanical energy that is then transmitted to the inner ear through the oval window into hydraulic energy. That energy is changed to electrical energy and sent on to the brain. We have to also understand that anywhere along that process, there can be an incidence of disease, damage, or interruption that might impede the flow of communication. So what might that look like? Well, if we talk about the outer ear, certainly you might be familiar with things like swimmer's ear. This is that part of the body of the ear that is exposed to the elements, right? So there are things that might impede just the localization of the sound. Um, so certainly deformities to the outside of the ear. So if the ear is misshapen or fails to form, there is a difficulty in localizing the sound. Once the sound is sent into the ear, if there's sort of a incidence of impacted cerumen, which is earwax, or swimmer's ear, which causes inflammation and swelling by too much water getting into the ear. These can impact the flow of that original sound wave coming into the ear and therefore impact the overall ability of the listener to interpret and hear the message. As we progress to the middle ear, we hear ear infections are a common cause of pain or fluid in the middle ear. Particularly in young children, one part of the middle ear is the eustachian tube. Its job is to keep airflow and the aeration of that middle ear space well clean and open. But sometimes in young children, that eustachian tube is quite small and fluid fails to drain from the middle ear effectively, causing ear infections, middle ear infections. You can think of it as if there's fluid in the middle ear, how it might be, like say if you were running in a swimming pool, how your motion tends to be slowed. Well, the same thing happens to the muscles or not the muscles, the bones of the middle ear, the ossicles. The motion of those ossicles also tends to be slowed, just as it might be when anything is impeded by fluid. When we have an infection or fluid in the middle ear, we usually experience this as a temporary hearing loss or transitory hearing loss. Once the fluid or the infection is cleared, then the flow of information is then resumed and hearing continues. But you can think of the impact on young children, especially if they have frequent ear infections, how the messages that they are trying to interpret as they're learning speech and language may be disrupted based off of how often they get this middle ear infection. So we can see the impact of frequent interruptions to the hearing process in a child who has frequent ear infections. Some children function quite well despite having frequent ear infections, and we do see some children who, having the same type of ear infection, have more of an impact to their speech and language development. Inner ear issues are often when people are exposed to loud noises, loud music, jets taking off, drills, construction kind of noises. Often the disruption to the hearing in the inner ear is painless as opposed to what they experienced in disruptions in the outer and middle ear. However, the damage that can be done by loud noises is done to the hair cells in the cochlea, and this hearing loss is permanent. Hair cells do not grow back in the inner ear. They do not regenerate. So once they're gone, and that is a permanent hearing loss. We classify hearing losses a little bit different depending on where they happen. So if a hearing loss happens in the middle ear, we often term this as a conductive hearing loss, and that the sound wave is not conducted well to the rest of the hearing mechanism. When the hearing loss occurs in the inner ear, we classify that as a sensory neural hearing loss because it is impacting the sensory and neural impact of the sound. Okay, so as you think about the hearing process this week and how everything must work together just seamlessly, realize too that these minor and sometimes major impacts to the hearing process can also impact a child's speech and language development. Have a great week, and I will see you next week.